Guy from Kaspersky ICS CERT, Vladimir Dashchenko.
Let me please introduce myself.
Okay.
I'm a man of wealth and taste.
I will be speaking in English, so it will be easier for all of you. And I see that everyone is delivering the speeches in English, so I will try to keep it up. So, as I mentioned in Russian, most of us, we try to protect cybersecurity, we try to protect industrial control systems, try to higher the level of industrial cybersecurity by making classical steps. It's all good, and it's a perfect way. So today I would like to talk to you, and actually not talk, but discuss with you another side of the moon. Is there a chance to run a bug bounty program for industrial control system vendors? Is there any possibility? So, who knows about bug bounties? Okay, so some people know about bug bounties, that's good. Let me briefly describe what bug bounty is. Basically, bug bounty program started a little bit more than almost 20 years ago. So the first bug bounty programs were basically, they were all about when cybersecurity researchers were reporting vulnerabilities to different vendors, and the vendors were trying to give them bounties. First bounties were made with some t-shirts, hats, cups, coffee cups. And later, vendors decided to speed up bug bounty programs by offering money. So they decided to pay money for reported vulnerabilities. So how does bug bounty work? Basically, you hack and they pay. Well, for this audience, I guess it's better to say they hack and you pay. Maybe it will be easier to understand. How does it work in general? So there are two main streams how to get bounty for the bugs. First, if a vendor has official bug bounty, you can report a vulnerability directly to the vendor as an independent cybersecurity researcher. Vendor receives your report, confirms that there is a security issue, and pay you some money according how the vulnerability, how critical vulnerability is. The other example is when vendor is working together with some sort of bug bounty platform. So cybersecurity researcher reporting the vulnerability through the bug bounty platform to the vendor. Vendor receives the report, says that, okay, there is or there is no vulnerability, and after the fix is released, they pay money, or they, I don't know, provide some points or something like that to the cybersecurity researcher. There is another way, the third one, so we will discuss it a little bit later, just touch the topic. It's exploit broker platforms. How does the platform work? The normal bug bounty platform. So there are two major bug bounty platforms, HackerOne and Bugcrowd. So Kaspersky Lab works with the HackerOne platform. We have official bug bounty. And according to the statistics of HackerOne and Bugcrowd, so almost more than 340 companies work together with HackerOne, and almost 1,000 companies work with the Bugcrowd. The total amount of all bounties since 2012, the total amount of bounties was something around $11 million, almost $12 million. This is the statistics from HackerOne. And only for 2017, $31 million oh, I'm sorry, almost $12 million were paid only in 2017, and in total it was they paid $31 million. So if we're talking about the vendor-specific bug bounty programs, well, it's a big deal. So Microsoft, for example, pays $300,000 for a chain of vulnerabilities that can compromise Azure. And they pay up to $250,000 for a chain of the vulnerabilities that can compromise Hyper-V. This is a virtualization platform. Intel has bug bounty up to $100,000. Kaspersky has also the bug bounty up to $100,000. And the Google just raised their bounties up to $150,000 for Chromebook and Chromebox. So those are really good money, right? But, well, what do you think? Are there any bug bounties ever existed for industrial control systems? Yes or no? Who think that yes? Okay, not so many people. There was the only one. There was the only one company. So I found in open source, in publicly available data, only one company. The company is called Ekava IGX, and they offered bug bounty program for their product called Integrexor, HMI SCADA. But they said that they are offering non-monetary bug bounties. So what does it mean? They do not pay you in money. They pay you in some sort of points. What can you do with these points? Let's take a look. Basically, you get different amount of points according to the reported vulnerabilities, and those points you can transfer into the money, but you can buy for this money the license for the software. So just imagine a general, average cybersecurity researcher from some country finds the vulnerability, right? And the company offers him or her okay, so now you can get our license. Well, maybe that was the lucky guy who always wanted to get that official license of that software, maybe not. And according to the publicly available data, this company had several bug bounty reports since 2013 up 2017. And if you can see on the very bottom, there are two gentlemen, they reported through Zero-Day Initiative. So Zero-Day Initiative, it's not bug bounty platform. This is some sort of exploit acquisition program. Let's take a quick look on the statistics of vulnerabilities in industrial control systems. So these statistics was done by our team based on the US ICS CERT data. So we took the statistics, we took the data, vulnerability data for 2018, did some analysis. So for 2018, there were 415 vulnerabilities reported, and they made them publicly available. And if you will take a look on the statistics, you will see that two top types of the vulnerabilities belong to buffer overflow and improper input validation. That means that those two types of the vulnerabilities highly likely were found using different fuzzing techniques. So usually those types of the vulnerabilities are found when cybersecurity researchers are doing some fuzzing, automated vulnerability analysis. And from year to year, if we will compare 2017 and 2018, we will see that the number of such vulnerabilities are growing. So that means that external cybersecurity researchers, paying more attention to the vulnerability to industrial control system software and hardware, and they implement their knowledge and experience in fuzzing into the ICS stuff. So if they find more that type of the vulnerabilities, that means that internal security teams of vendors, they might use different approaches and technologies to do the fuzzing and automated analysis. Let's take a quick look. So what do we have right now? How do we get the information about the bugs? How was the bug born? So we have 4 main streams. First, well, bug bounty. We know a little bit about bug bounty right now. So the second is in-house research. This is the product security teams that are usually vendor has. The third one is external service provider. That's a common thing when a vendor has external company who does the penetration testing or security analysis, security assessment for their products, services, web applications, software, hardware, anything. And the fourth, as I mentioned before, exploit brokers. But there are some shady exploit brokers, and they offer, so those guys, they are really competitive. They offer more money. For example, lately one of the exploit brokers has raised the amount of money for remote code execution in Android operation system up to $2.5 million. That's quite big money. So if we have that pretty good experience of general IT companies in terms of running bug bounty programs, what are possible stop factors? So all the stop factors that we have here on the slides, where it's my imagination totally. So the first reason, the first stop factor that I think exists, it's, well, that might be too expensive for us. This is what vendor can say. I did some analysis of typical payouts for the vulnerabilities identified in classical IT systems. So in classical IT systems, they pay something around $500 for just general denial of service. It's not that critical for classical IT systems, which totally makes sense. Cross-site scripting, it's something between $200 up to $1,000. Of course, if there is a stored cross-site scripting in, let's say, Gmail, it will be, I guess, more expensive. Different types of the injections, like SQL injections, from $2,000 to $6,000. Information disclosure can be, well, starting from like $500 up to $20,000. And remote code execution, it's quite expensive. It can be really, really expensive, something around like $300,000. But in general, it's something between $4,000 and $25,000. And 2 other types of the vulnerabilities. So I decided to think like what can be possibly, how it can be possibly transferred to OT software, industrial control system software. So I believe that denial of service for industrial control system software will be a little bit more expensive because, well, if there is a denial of service in, let's say, a PLC device, well, that's more critical. Cross-site scripting injection, so I decided to take on the very bottom line, so it less critical than for, let's say, general IT companies, banking, software, something like that. Information disclosure, I believe, so it should be something around like $5,000. Remote code execution around $5,000, and so on and so forth. So let's try to calculate, is it a lot or is it not? So we again took the data, publicly available data from US ICS CERT, did some analysis. We took one of the top vendors who has disclosed vulnerabilities, and that vendor has 40 vulnerabilities disclosed in 2018. So we did a very quick analysis. So they have reported and disclosed 5 remote code executions, 29 denial of services, 1 problem with the certificate validation, 2 cross-site scripting vulnerabilities, some missing authentication, which for some reason leads to denial of service, So one path traversal and local privilege escalation. So local privilege escalation is that type of vulnerability when, let's say, attacker has a remote access to remote system, but attacker has a very low privileges. So exploiting this vulnerability, attacker can get a system privileges or let's say administrative privileges. So it's quite common problem. They usually pay a lot for this type of vulnerability, but less than remote code execution. So in total, we have here $63,000. So is it a lot or is it not a lot? I don't know. It depends on vendor. But I can definitely say that if we're talking about, let's say, North American vendor or European vendor, this is maybe, I guess in the United States, it will be, this price is less than a general average salary of cybersecurity researcher. The second problem, the second reason why vendors do not start the bug bounty programs is the maturity problem. So last year I did a research for Zero Nights conference. So I did the analysis of all the communications that we had with different types of the industrial vendors, and I decided to, to put them into the 5 stages of grief, and it works pretty good. So most of the vendors, they go through all the stages: Daniel, Anger, and up to acceptance. Some of the vendors, mature vendors, they already went through all the stages and they're on the last stage. So they know how to work with external vulnerability reports. But unfortunately, most of the vendors, they are somewhere really close to depression. And that's bring up another problem. So yes, only several vendors, they know how to work with internal and external vulnerability reports. And that brings another thing. The smaller amount of vendors know how to work really close with research and development team internally and how to do the prioritization of the vulnerability reports. We have several examples. There is like one huge vendor, We have reported the vulnerability in PLC devices. They said, yeah, that's the problem, and the vulnerability was quite bad. They said, yes, the vulnerability exists, and they said, we're not going to release the security patch, which is going to fix the problem in the next generation of the PLC devices. And well, they shouldn't do that. They should, work with the vulnerabilities, properly. I know that there is a problem how to release the patch for PLC devices, how to upload the patch, and so on and so forth. But well, they should do something with that. There is another problem. It's very difficult to to track what open source and third-party code you use. I mean, vendor uses in their setups, in the SCADAs, in the PLC devices. Again, I know only one company, one big ICS vendor, who has a very good thing. They have built an internal monitoring tool, so they know what type of the open source code they use, and they constantly monitoring if there are any publicly available vulnerabilities, reported and disclosed, which they can, take that information and automatically start, fixing in their code. The third reason, in-house research challenge. So that's a very good thing that a company has internal offensive team who does the vulnerability research of their solutions. It's a very good thing. So they will very easily and very early fix most of the vulnerabilities, hopefully. And some of the vendors, they think that it's more than enough. Well, it's not. The fourth reason, the final, we have external security team. Well, it's really more convenient. You sign the contract, they do their job, and you receive the vulnerability report, technical report, and you start fixing the vulnerabilities. Works pretty good. And it's more confidential, of course, than bug bounty programs. Because most of the bug bounty programs, they are publicly available, so you can go online and see what's happening. For all those things, for all those reasons, I have counter-arguments. So let's see. It's too expensive. Yes, it might be too expensive. It might be expensive for several specific vendors. But if you are going to bug bounty, the bug bounty should be the last step in a very long thing called, building internal processes. If all the internal processes are built in a good manner, if you know how to work with the external vulnerability reports, if you know how to work with your research and development team, if you know how to do the prioritization of vulnerability reports, maybe it's time to go and release the bug bounty. Maturity thing, well, it makes sense, but the maturity is totally belongs to the vendor. They should know how to become mature. In-house research challenge. Yes, that makes sense, but it's a huge challenge to build a strong offensive team. First, you have to find the good cybersecurity professionals. The second, you have to train them, and they have to do also not research in terms of your technologies, but also the technologies around. So they will know how to do the attack and defense thing. And another problem, we have seen several examples when the internal offense team works really too close with the research and development team. So they have a very limited scope for the offensive things, and that's the problem. So they do not go full-scale vulnerability research. But if we're talking about the real attackers, real hackers, they do not have limited scope. They have unlimited scope and unlimited time. Established relationship with one external, or not one, several external security teams. Well, that thing really can be expensive. And you have signed contract with only one team. And they definitely have a limited time and scope. If you want to, extend time and you want to extend scope, it costs you money. So what are the bug bounty arguments then? Well, first of all, of course, it's obvious thing. Bug bounty will make your product, your technologies more secured. By the end of the day, it will be more secured. A lot of people will be, trying to penetrate your software and try to identify different types of the vulnerabilities. They totally make sense. The bug bounty should be, and it could be, a motivation to build your internal processes. That's a very needed thing for most of the industrial vendors. It's also a great opportunity to enhance the level and the knowledge and experience of your offensive teams. You will invest time into the trainings. You will teach people how to, do fuzzing, how to do different types of the vulnerability research. And, well, by the end of the day, you will have a very highly skilled team. And though that team will also know how to work with external reports, they will basically have knowledge exchange program with external researchers. And they will understand the mindset of the external vulnerability researchers and can adjust it for your internal vulnerability research processes. It will also increase the level of trust for your products. So if you will do a round of the bug bounty, then you can use it in the marketing materials saying, okay, so we went through all these stages. And so right now it's super secured, 100,000 people were looking into our code, and well, it's it is secured now. And the last but not least thing, the bug bounty will, by the end of the day, make this world a little bit more safer place. So my talk was is it fantasy or reality? But let's talk about like from fantasy to reality. Is it possible or not? It is possible, and I believe that the first step for industrial vendors can be basically a private invite-only bug bounty program. Most of the vendors, the industrial vendors, they usually know who is usually reporting vulnerabilities. Well, those are companies or private researchers. It doesn't matter. But you can basically, create some sort of a contract, an open contract with the different teams, and you will just provide them the list of types of the vulnerabilities. And you will say, okay, if you find remote code execution, we will pay you like this amount of money. So it will be a bug bounty program for the companies. And it's a really good win-win situation. So the external security service provider will be motivated to find more vulnerabilities to get more money. And the vendor will totally know how much money they spend for what types of the vulnerabilities. And this is not like, my final thought and saying like, okay, so we need to work on this thing. No, it's some sort of thing for a discussion. Maybe you will have some ideas. Maybe you know how to do it better. Maybe we can create something new together. So I will be happy to discuss this whole thing together on the coffee break. Thank you.